Greetings to all those who chose to watch this video presentation, which is going to deal with the South African Mathematics Olympiad paper that was written in March 2021. At the present time, it was just a few days ago. The particular paper that we are going to examine today is a paper that was set for the junior round, grade 9. There are two junior papers. One is grade 8 and one is grade 9. Of course, one senior paper for grades 10, 11, and 12. So we are going to focus on the grade 9 junior paper of the first round of the South African Mathematics Olympiad 2021. So let's get going immediately. And I'll share this screen with you. As you can see, we are doing the 2021 Junior Grade 9 Round 1. All right, the very first question in this paper is a simple sum, adding three numbers. And so it's nothing more than a test of the test of how to add decimal numbers. One can do it mentally. Excuse me, please. One can do it mentally if one knows how, but that would take a chance. Let me show you how to do it so that you can get the correct answer very quickly. Okay, so here we go. You've got 20, 21. Okay, when you add, you put the 20 underneath it. The decimal, there's no decimal, so it's actually 0, 0. And then you have 2, 1. And of course, there's nothing there, so you can regard that as a 0. So make sure the decimal points are under each other when you're adding. And now, when you add 1 plus 0 plus 0, 2 plus 1 is 3, and then 2, 4. So the answer is 42,31. All right, so let's get on to the next question. It wasn't a very challenging question, as you can see. So, question 2. Says the time now is 2021. This is, in other words, it's 21 minutes past the 20th hour, which is 8 in the night. So it's just past 20 past 8 at night. What will the time be after 200 minutes? Right, obviously we have to retranslate the 200 minutes into hours and minutes so that we will be able to solve this problem. So how do we do that? To translate 200 minutes into hours, you have to divide by 60. So when you divide to see how many 60s there are in 200, now 3 60s makes 180, and the remainder is 20. So this means that 200 minutes is the same as 3 hours and 20 minutes. And we have here the time now is 20 hours and 21 minutes. Okay, so in 3 hours time, the time will be 20 plus 21 is 41 minutes. 20 plus 3 is 23 hours. So the answer is 23 hours and 41 minutes. And to write it in the same notation as this, then it's nothing else but 23, the colon, and 41. So the answer is 23:41. All right. So the next question is, number 3, which of the following is closest to a quarter of 2021? Which of the following is closest to a quarter of 2021? So there are 5 numbers given there, and you have to choose one of them. So to do that, you firstly have to find out what is 1/4 of 2021. In other words, divide 2021 by 4. What do you get? You get 4 goes into 20 5 times, 4 goes into 2 0 times, 4 goes into 21 5 times, and the remainder is 1. So 2021, 1/4 of that is 505, and the remainder 1 means it's 1/4. Okay, so the number which is closest to this number here, if you look at these 4 numbers, this is 505 1/4, and the answer is clearly 505. Okay. So we're now going to problem 4. Problem 4 is, you've got a double square root here. So one has to be a little bit cautious. Remember the 2 square roots. So let's look at the outside square root. The inside square root, well, we can add those numbers. What do you get? You get 20 plus 20 plus 20 plus 21. Okay, that is 40, 60, 81. So this is the square root of the square root of the square root of 81. Now, square root of 81, let's do that first. That is 9. Right, so this replaces square root of 91. I'm writing 9 for it. That's the square root sign then falls away. So the outside square root is still there, and the answer is 3. Square root of 9 is clearly 3. Okay, so that's the answer to that question. Question 5. A whole number between 10 and 30 has the following properties. The number is not even. Okay. It is not even. It is not a prime number, and it is not divisible by 3. Okay, there's a lot of information given here. So how do we unpack that? Well, let's have a look at actually, I think the question was 20 and 30. Sorry, this question is written wrongly. Sorry about that. It is supposed to be 20 and 30, as I recall. Okay, so we want to look at a numbers between 20 and 30. So it's going to be, what are the numbers between 20 and 30? Let's list them down. 21, 22, 23. I understand by between, it means it doesn't include it. Although some people might dispute that, but if we expected these numbers to be included, we should have said included, inclusive of 20 and 30. We didn't say that. The question didn't say that. So let's have a look at these 9 numbers. These are the numbers between 20 and 30. It is not even. Straight away, we can start eliminating. So it's not one of these even numbers. It is not a prime number. Well, let's look at what are the prime numbers. 21 is 3 times 7, so that's not prime. 23 is, so we can take that out. 25 is obviously not a prime number. 5 times 5 is 3 times 9. And this is prime, so we can remove that. Okay, so what are we left with? Most of the numbers are disappeared except 25 and 27. Those are the only survivors. And I think also 21. All right, so there are 3 survivors here, but it's not divisible by 3. So that's the last fact that is given. So this is divisible by 3, we eliminated. 27 is also divisible by 3. So of those 3 numbers, 2 of them are eliminated. And the only survivor is 25. So the answer to this question is 25. All right, let's have a look at this next problem. There's a long story here. A house is in the shape of the shaded area. Okay, so the shaded area represents a house. Okay, maybe you're looking at it from the top, maybe. The back of the house, the front of the house, the sides, and so on. And the 4 square gardens at the corners of the property. So these are all gardens here. Right. The entire property is also in the shape of a square. So the entire property is in the shape of a square. Right. And its area is 400 square meters. Right. Square meters. Now, if the area is 400 square meters, then the area of a square is side times side. So we can translate, we can make use of the information to get a side here. This number multiplied by itself gives you 400. That's the area. The area is a side multiplied by itself. Right? It's actually length times breadth, but the breadth and the length are the same thing in a square. So therefore, we can say it's a side times side squared. Which number multiplied by itself gives you 400? The answer is 20. That's clear. 2 times 2 is 4. And so you get 20 times 20 is 400. Okay, so we've got the side of the square. Now what is the question? The question is, what is the perimeter of the house in square meters? All right. Now, this involves adding a lot. Perimeter means adding the boundary of the object in question. Yeah, the house has got this as a boundary. It's a rather complex boundary, as you can see. There are lots of sides here. And we don't really know what each one of them is. We don't know what these are. It's not given. The only thing that is given is the area of this whole thing, which allows us to calculate the area, the side of this large square. Right, so there's a little thing that we have to observe here. And to that end, I've drawn a diagram to illustrate what we are going to observe. And let's get to the next picture. I've redrawn this thing. Okay. So just bear in mind the side of this thing is 20. Now this is the original thing. What I've done here is I've moved the internal boundaries here. The boundaries of this house, which are inside the square, I've moved them all to the edges, parallel to itself. So I took this one here and I moved it there. So this blue one here is the same as that, right? This is a square, you see. So here to this edge here, this is not coming out very clearly. Let me just use this then. This edge here, I moved it there, parallel to itself. Likewise, I moved it there, moved that there, and did that to, so you got all these blue lines on the edges are just the internal boundaries of this house moved to the edge of the square. So when we are adding, for instance, this and this, we might as well add that and that. And when you're adding this and this, we might as well add that and that, because it's the same thing. And say likewise when we're adding these two and also these two. Because remember, we are working on the perimeter of the house. So it's the perimeter of all these dotted lines, the sum of all these dotted lines, plus this black line, and then some of these two dotted lines, plus the black line, plus the two dotted lines, plus this black line, and so on. Now the dotted lines I've already ticked off. The only things we haven't ticked off is the black lines. So we must still add, so we will add up all the blue lines and especially, and also the black lines. We need to add that and that and that. All these form part of the boundary of the house. So when you add up all these boundaries, what do you get? You get the entire side here and the entire side here and the entire side here and the entire side here. So the perimeter is actually equal to 20 plus 20 plus 20 plus 20, which is 80. See? So this was a little trick to add a rather clumsy looking object, but when you do what I did, you see that it becomes quite straightforward. All right, so that takes us now to the next question, okay, which is okay, so that question is there on the screen. What is the largest two-digit number that is the sum of two different perfect squares? What is the largest two-digit number which is the sum of two different perfect squares? All right, so we want to add two perfect squares, and they must be, you can't have them with more than two digits. So let's just write down all the squares that we know, which have got two digits, or even less. We're starting from 1. Let's write down the squares of 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm stopping at 10 because 10 times 10 is 100. Okay, that moves to 3 digits. So now we want to take the squares of these numbers. 1 squared, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 49, 64, 81. And we can ignore 100 because that's a 3-digit number. Now, let's go look at it again. This is the sum of two different perfect squares. So I'm going to work the sum of two perfect squares. Right? and I want to get the largest possible sum. Okay, so let's start with 81 and add it. 81 plus 64, I want it to be as large as possible. So let's take the largest of these things. Now this obviously is a 3-digit number. 81 plus 49 again is a 3-digit number. 81 plus 36, 81 plus 25, right? 81 plus 25 is 106. But when we come to 81 plus 16, you get 97. Okay, that seems to be the largest 2-digit. In fact, it's a very large 2-digit number. So the only question is whether 98 and 99 are also the sums. Whether 98 and 99 can be possible answers. All right, let's not go into that. And we finished with 81. Let's try 64 and see what are the largest possible sum you can get with 64. Now, if you do the same thing looking for 2-digit numbers, you'll see I'll get 64 plus 25. Because 64 plus 36 is 100. So the next number that you get is 64 plus 25, which is 89. So that's certainly not larger than that. And then that is the largest 2-digit number you can get involving 64. And then if you go on to 49, well, obviously now when you take 49 plus, even 49 is 98. See, but you're not allowed to add 49 and 49 because they say they are two different perfect squares. So 49 added to anything else is smaller than 97. So quite clearly now, this is the largest. No other possible sum will be larger than 97. All the others are smaller. All right, so that is the answer to question 7. So let's go on to the next question, which is question 8. Okay, here we have a diagram. Let's see what this diagram is. So 2 equilateral triangles overlap as shown. So these are equilateral triangles. An equilateral triangle here, and another smaller equilateral triangle. And you're asked to calculate the value of x. All right, now there's one important fact about equilateral triangles, and that is, well, 2 important facts. All the sides are equal, and not only that, all the angles are equal. And the angles are all equal to 60 degrees. Right? Okay, so the sides and the angles are equal, they're all equal to 60 degrees. It's important to know why it's 60 degrees. Let me just explain that quickly. See, if you've got an equilateral triangle, all the sides are equal. So it means that this side is equal to this side is equal to this side. But you know that if you got, this now becomes an isosceles triangle. So if this is x, in an isosceles triangle, the base angles are equal. Or more precisely, the angles opposite the equal sides are equal. But you also know that this is equal to this, so even that angle will be the same thing. So now you've got all these angles are equal, but in a triangle, the sum of the angles is 180 degrees. So you got 3 x's 180 degrees. So the angle in question is 60 degrees. So that tells me that the angles of any equilateral triangle are 60 degrees. So this angle is 60. So this is an angle of equilateral triangle. I went to this. I'll tell you why. Because you see, this is x. Now, vertically opposite angles are equal. It's one of the things you learn in geometry, that if you've got 2 straight lines intersecting, then the angles which are directly opposite each other, they are equal to each other, vertically, these are called vertically opposite angles. So this angle equals that, and that angle is equal to this. All right? So vertically opposite angles are equal. So this, if this angle is x, this angle is also x. All right? Now, for the same reason, you've got, if this is 40 degrees, this angle here is also 40. So now in this small triangle here, you got three angles. One is 60, one is 40, and the other is x. And we know that the sum of the angles of a triangle, sum of the three angles of a triangle, is 180 degrees. So we've got x, when it's added to 100, you get 180, so x must be 80. What number, when added to 100, gives you 180? And says 80. Or if you like, you can bring the 40 and the 60 to the other side. Then you have to subtract 40 from this and then subtract 60 again, and you'll come back to 80. So the answer to this problem is 80. Right. So let's go on to the next problem, which is problem number 9. Problem number 9, let's read this problem here. If you can only travel in the directions indicated by the arrows, how many pathways are there from A to B? So you got A and you got B here, and the arrows are not very clear, but let me, let's get the spotlight on this thing. So you have, this arrow is pointing this way, downwards, downwards, downwards. All these are downwards. On the boundary, it's all downwards. In fact, it's always downwards. Always downwards. Okay, now, how many pathways are there from A to B? Now, this is a kind of a standard problem. It's there's a very nice way of solving problems like this. Sometimes you have problems with rectangles, in a rectangular grid, and there's a certain strategy that is used. Like, I'll just show you an example. So if I got, let's just do it nicely. If I got a rectangle like this, and suppose I got sorry, I should have chosen something else here. Okay, so suppose you got these lines. Let's just get this thing right. Okay. Let me explain the problem. Now, I'm going to give you another problem which is similar. It's the same principle which will be used to solve this problem. So suppose you want to travel, you got two houses maybe. Right. You got two houses, A and B, and you want to travel from A to B. In how many ways can you do that? Now you can see, you can do this. This is one way. Oh, by the way, if these arrows are all going towards the house, you're not allowed to backtrack. You always move as if you're going towards the house. So this is one way. This is another way. And this is another one. And this is another one. So it can be quite complicated. So the way to do this is from A, let's start from A, and we write down get to this node here, how many ways can you get from A to this point here? The answer is only one way. Right? And then from A to this point, how many ways? That way is only one way. Likewise, you can have ones there like that. There's only one way when you can get to this. Now watch. If you go to the middle one, here, right, you can go that way or that way, or that way and that way. Right? The point is, this is very important, that the number of ways you can get to this point here is equal to the number of ways you can get to that, and plus the number of ways you can get to this point. These are the only 2 points which lead to this, right? So you can get only one way to this point, so that gives you only one way to this. You have to add them up to get to 2. So there are 2 ways to get to this point here. Now, to get to this point, you do exactly the same thing. There are 2 ways to get, 2 pathways lead to this point. This pathway, there's only one way to get to that point. In this pathway, there are 2 ways to get to this. So therefore, there are 3 ways to get to that point. See? So if you follow this principle, again, there are 3 ways to get to this point here, right? Because it's 2 plus 1, and here it's 3 plus 3. So there are 6 ways to get to B. See? You can actually count them, because this is 1, this is 2, this is 3, this is 4, this is 5, and I think that there is 6. I'm not sure if I missed out, but there are 6 ways. So in the same way, if you do the same thing, here you'll have to put a 1 here, because there's only one way to get from A to this point. And again here, right, there's only one way. You see, this has got only one ancestor, that is A. Now, this point here has got 3 ancestors, because you can get to this point from there, or from there. So there are 3 ways of getting to this point. That way, or that way. Now, to get to this point, there are 2 ways. You can get it from here or from there. So that gives you 3 plus 1, which is 4. Right? To get to this point here. Why? Because to get to this point, you can only get to it from here or from there. And here there's 1 plus 3 gives you 4. In the same way, to get to this point, you can get to this only from here or there. So again, you get 4. So to get to B, now there are 3 ways in which you can get to B: that way, or that way. And you simply add those 3 numbers at those ends. And the answer is 4 plus 3 plus 4, which gives you 11. So the answer is 11. If you try to count the number of ways, it can be quite complicated. But this is a nice, very easy way of, in fact, very much more complex problems. You can do it like this, and much easier than trying to find out what all the pathways are. Okay, so let's move on to the next problem. The next problem is, we've now gone to problem 10. Problem 10, you've got 2 parallel lines here, and they ask you which statement is always true. And now this is just a question of trial and error. Is A equal to F? Now you must remember, in parallel lines, your corresponding angles are equal and alternate angles are equal, and co-interior angles are supplementary. You can't assume anything else. You can't assume A and B are equal. They are not alternate or corresponding or anything like that, for instance. All right, now, is A equal to F? Now remember, you've also got vertically opposite angles. So you got A equals C. Is C equal to F? Not necessarily. You can see they're not equal. So this is out. And you can go through all these and eventually you'll see that B will certainly be equal to H, because B is equal to D, but that's vertically opposite, right? And then D is equal to H because it's corresponding angles. So corresponding angles are F angles. If you didn't like that, you are more familiar with alternate angles, you could have done that. You could have come here, D is equal to F, and then F and H are vertically opposite. So you can get to H that way. So B is certainly equal to H. That statement is always true. That's the answer to that question.